Thank you very much. Today I will show you how we at Blickfeld develop a sensor technology that enables the mobility of tomorrow. So there are 20 billion cameras in the world. And you have to think a little bit about that number. That's really a huge number. It's actually 3 times more than there are humans on the planet. And obviously, we can recognize camera pictures very well. We know what is on these pictures. But surprisingly, computers have really a hard time to interpret these pictures. If you look at that picture, you see immediately that it's obviously a painting, that there are no real pedestrians on the street. But if you're an autonomous car and you use just cameras to see the world, then you would, even with AI, you would interpret this as pedestrians. And you don't want to have that. So the solution for that is very simple. Of course, you could use AI, but there's always a certain uncertainty, and you don't want to have that. So there are so-called LiDAR sensors, and these LiDAR sensors, they produce 3D images that computers can easily understand and process. And this is exactly what you want to have. And if you look at the self-driving cars of today, for example, here you see a fleet of Uber, then they all have this really large thing on top here. And these large, bulky things, this is exactly a LiDAR sensor. And actually, there's no robocar, there's no autonomous car out there at the moment that doesn't use such a LiDAR system. So let me very quickly introduce you a little bit to the technique of a LiDAR. So actually, it works like a radar. So you have a source that emits light pulses, laser pulses. They hit an object, they get reflected, they get detected, and from that time difference, so-called time of flight technique, you can measure the exact distance. So the thing is now, you don't want to just measure one single point, but you want to scan your whole field of view, or as we say, your whole Blickfeld. And to do so, you need to scan the laser beam, you need to deflect it. And this is what we call beam steering, or the so-called beam deflection unit. Now, LiDAR isn't a new technology. It has been out there for 20, 30 years, and has been used, for example, in the atmosphere to measure emission or for remote sensing in archaeology. So why don't we just use these LiDARs in autonomous cars? Well, the answer is very simple. If you look at that picture, we have here, this is a LiDAR in 2008. This is from the DARPA challenge, and it's a car from the Stanford University. It's actually one of the first robocars. And now, 11 years later, we see we still have that bulky thing here. This is a Waymo Google car. It's one of the advanced autonomous cars out there. And they still have that really large thing on top. And so in the last 11 years, there didn't happen much with respect to technology. And if you think of car makers, BMW, Volkswagen, Mercedes, and if you think of how important design is for them, then it's sure that this is not going to work in the future. You want to integrate them seamlessly, and you don't want to have such a huge, bulky thing on top of that car. And there's one maybe a little bit funny side remark. So you don't see the license plate of that car here, but actually there's written powered by diesel. And this is maybe something you wouldn't want to have on your license plate today, but back in 2008, Volkswagen thought that would be a really nice thing. So what does it take to get from these really huge things to the mass market? Well, the problem is that it's really a tough technological problem. And today's LiDARs, they are so-called mechanical spinning LiDARs, and they have a very complex design, and that makes it very expensive in production. So actually, these systems, high-end systems, cost $70,000 and more. And of course, that's not going to work for a mass production car. And they're produced just tenths or hundreds of pieces, but not in millions of them. And of course, the car industry, they know that they need these LiDARs, really. That's where they rely on for autonomous driving. So the need is actually to make them very small, to make them robust against vibration, shock, also temperature. And you have to scale the production. And that technology gap is unsolved up to date. And this is exactly where Blickfeld comes into play. So I told you that the hard part is really that beam steering, so where you deflect the laser beam over your scene. And this is what we really invented, something new. And we made that whole thing out of silicon. So no more moving mirrors or anything, but we made it out of silicon, so-called MEMS mirrors. And these MEMS mirrors are specifically designed for LiDAR in a way that you can see very far with your LiDAR. So we have ranges up to 200 meters. And that you also have a wide field of view, because imagine driving on a car, you don't want to just see like what is really in front of you, but you want to see, for example, cars or pedestrians coming from the side. And with this really new MEMS technology, which is on a silicon wafer basis, so you can produce it at high scale, at micro or even nanometer precision in large scales, we are able to build a revolutionary LiDAR. And the thing is, where our competitors use like a really expensive so-called optical fiber lasers, which you see here on the left, where alone the lasers, or just the light source, this is not the whole LiDAR system, it's just the light source, cost over 10,000 euros. We can use like an off-the-shelf component, and we use like a low-cost laser diode, for example, which you can buy from Osram, and this just costs you a few euros. And with our special MEMS mirrors, our beam deflection unit, such a tiny laser diode is enough to see 150 of meters, and especially it reduces the cost significantly. So this is what our LiDAR looks like. Even though it's now pretty large here on the screen, you see here for size comparison, you see a credit card. So the whole thing really has about the size of a credit card or a business card. And it has some really nice features, which I'm not going to annoy you at the moment, but I can tell you this is exactly what the car industry is looking for. And the small size makes it really appealing for car designers to design it, for example, in headlights or other places of the car. So far, we talked a lot about mobility, about autonomous driving. And why is that so? Because every car maker knows that they really need LiDAR. For example, to create high-dimensional precision maps to detect objects and to navigate. But this is just one market, and this is a huge market. Goldman Sachs says this market is going to be like $35 billion in 2030. But there are many other applications. If you, for example, think of putting these LiDAR sensors not in the car, but put them in the infrastructure, for example, in traffic lights or traffic poles, you can detect, for example, free parking spots, you can detect traffic in real time, and you can have all kinds of information that is really on a geometric scale. Here you see an example of a car parking in. It is right in front of our office in Munich, and you see that a car parking spot turns green. Another example is security. So you can, for example, detect humans in crowds. And you see here an example, for example, here's what we call a danger zone, and a LiDAR can detect people in there. But the good thing is, unlike a camera, you don't have like face recognition. So you see that there is a person in there, but you don't recognize the face. So you don't have data privacy problems. You see that there's a person. You can, for example, make an alarm, but you don't have any data privacy problems. You can put these LiDAR in the public space without any problem. So let me tell you a little bit about Blickfeld. We are quite a new startup, so we are just 2 years old. We have been founded in the beginning of 2017 by 3 founders. 2 of them founded a sensor company before, so they know how to build such a startup. And the third guy is a robotics guy who has a lot of experience in environment perception. And from robotics, he knows that really environment perception is the key. We received seed funding from 4 investors. We increased that seed round last year to overall 10 million. So I think that's pretty good for a German startup. And we have showed our technology to all the big car makers and also the big suppliers, not just from Germany, but basically to all over the world, and got pretty good response to that. So we are partnering with some of them already. And one thing is really important, as I said to you. So we're not up to building like 10 or 100 or 1,000 of these devices. So we're really up to building eventually a million of these devices. And this is why we partnered also with a production partner from Singapore and Taiwan, and they're going to produce our LiDAR system starting at August or September this year with fully industrialized production methods. So we are able really to produce thousands or even 100,000 of these LiDAR samples. And I think that's really a good message. So if we come back to that camera picture, with our LiDAR technology, we will really enable a wealth of application. Everybody is talking about digitization and IoT and the Industry 4.0. But the thing is, for that, you need data. And camera pictures are a nice thing. We're not going to replace them, but we're going to put a LiDAR next to every camera. And by this, we're going to enable the applications of tomorrow, like mobility, and change the life of millions and even billions of people. Thank you very much.